Okay, I thought I'd just do a quick tutorial for this commuter craft test case. So yeah, so I've got a solution file here in the working directory, octree.vtk, and I've got the aircraft. So I'll just load both of those in. So I load in the STL file. That's that. Load in the VTK file. Zoom out. So first thing you probably want to do is to look at the aircraft surface. So first step would be to cell data to point data, because you need the point data to do a contour surface. So that's extrapolating the cell centers to the cell points. As soon as that's done, you can then select the contour one. It becomes visible. So click on that, and that's a contour surface. So let's switch off the STL. That's a contour surface, which doesn't mean anything useful at the moment until you go over and select distance. So I want to take contour surface of the distance field. So then we set the distance to 0 because we want the distance that is at a value of 0, which means the surface defined by the STL file. That seems to have taken quite a long time to. It doesn't normally take that long to process it. Anyway, so that's our distance field. And if you toggle on the aircraft geometry, you can see it's a bit different because where you've got thin surfaces, the distance field breaks down because the mesh is not fine enough to capture the trailing edges. So that's something to bear in mind. And this distance field I'm talking about, if we take a slice through the domain, a Z slice, there you can see the refinement levels. So starting at level 4, 5, 6, 7, 8, up to 11. And if we select distance, this is the distance field that we're talking about, which is basically, well, it's very similar to the LCD, because basically you've got a dead region, which is value 0, you've got a live region, which is value 1, then you've got the cut cells, which are a value 0. So that's the LCD, which means live cut cell or dead, is basically an integer field that describes the geometry. If you go to distance, then that's your real values, which is the actual distance. So that has negative values and then 0 values, and then positive values. So when you take the contour of the distance field, then you're just basically looking at the contour of the zero surface. So that's a really handy way to look at your geometry surface. And it's also a good way of checking that your geometry is actually watertight, because it's not watertight, then you won't have this dead region on the inside, and everything will be red because it's leaked through. So if you've got a good distance field surface, then in theory you should have a good flow solution, and on that you can plot velocity, for example. Oops. Velocity. Select the wrong one. Pressure. So if you want to look at CP, I think we want to use a calculator function. So press calculator and scalars. So where it says result, you could type in CP. Type in a function. Switch that off. Divided by half times density times velocity Well, velocity squared, it's 30 to 900. And I think these are supposed to be the free stream values, so 1.25 or whatever it is. So that is our CP function, I think. So then I can select CP from the top there. And that gives you your pressure coefficient. Anyway, so if you want to do streamlines, cell data, point data, like streamlines, and that has to be done from after you've done cell data to point data. And the streamline thing in with UFO-CFD is a little bit quirky because you have to change one of the values to get it to work. So instead of interpolator with point data, select interpolator with cell locator. And then you get continuous streamlines. It's to do with the interpolation between the cells. So yeah, so let's seems to be going very slowly, as if something's running in the background. Which I don't think it is. Anyway, there's some streamlines, and you can change that to solid. Change that to 0.1. Okay. And you could also take a slice through the domain if you wanted to have a look at the background mesh just for reference. Surface with edges. So unclick show plane and click triangulate. Then you could put a level on the background just to make the mesh look nice. Yeah, so that's how you can do a bit of post-processing. And one useful feature in PowerView is to save state. So if you've got it's taking a while to set up a case, then you can do save state. So save it as PVSM. Then when you load in PowerView next time, then you can just basically go straight to load state. And that'll save you a bit of time setting things up. And the other thing I wanted to show was get rid of some of these contour. Yeah, if you're not comfortable using the distance field surface, the alternative is to interpolate the flow solution back onto the original STL file, which is quite handy sometimes. So you can use this feature or this filter, resample with dataset. So you select the input is your flow solution, the source is your STL file, select OK, sit back and wait for a few moments. And eventually it really is normally a lot quicker than this. Wouldn't be surprised if Avast is doing something in the background. Running incredibly slowly, using all of the processors. Hmm. Anyway, so yeah, once you've resampled onto the STL file, then you literally get the flow solution mapped onto STL file, which is sometimes a bit cleaner looking than when you use a distance field. But beware, because sometimes it will look worse if the STL file is quite coarse, because it interpolating the flow solution onto an STL file, which, I mean, this one is not too bad. But yeah, where you've got things where you've got long triangles, like you have on the wings there, the flow solution is extrapolating onto very long triangles, so it's going to look quite, well, it's not going to be very good. So you want a nice sort of uniform STL file if you want to use that resample with dataset feature. Anyway, that's it for now. Bit of a clumsy demonstration. Sorry it took so long because my computer's running extremely slowly, but there you have it. End of demonstration.